I'm going to talk about my PhD dissertation research in the past 6 years that I've done, and it's going to be on how machine learning transparency affects decision making. And I think I'm going to just minimize the screen so that I can see. But if you have any questions or things, just let me know, Alona. Thank you. Okay, so I want to give a little bit of background about myself first and how I started this whole journey of getting into human factors. So I started my Bachelor of Information Technology from the Australian National University in Australia, and then I moved to do my master's in human-computer interaction and design in Paris, University Paris Sud, and then I finished this master's at KTH, Royal Institute in Stockholm. And then also I went to work for ABB Cooper Research Center in Västerås in the UX group for a bit. And after that, I actually came across my PhD supervisor who was giving a talk to us at ABB about human factors. And I hadn't heard of human factors before that. I knew a lot about HCI, user experience, but human factors was very new to me. And I was like, oh, that's cool. I will travel to Canada for that, I guess, and spend the next 6 years trying to get a PhD degree from the University of Toronto working on human factors. I do find that they have a lot of similarities, and I'm really glad that I got to learn both kind of coming from the computer science, like the UX coming from computer science field, and also human factors coming from industrial engineering. It's very good. I get to network and interact with both researchers, and that's a great opportunity. And recently, after I graduated, I started working at Candu Energy, AtkinsRéalis, and as we know, some people are familiar with the company. And now I'd like to talk to you a bit about, now after this background, a bit about my research and what we've done. So I know, like, we talk about automation is being very beneficial, and we'd like to always be told that we should automate things, and we would be more productive, and things would be done more efficiently. However, as we know, as UX and HF and researchers and designers, there are always costs to over automating things, and I have listed some of these to go through with each other. And the Simpsons episode is also very funny because it replicates that, kind of reflects that over automation and frustration that might come with it. So one of the things that operators struggle from over automation is the loss of situation awareness and not being familiar with what's going on and what stage is the automation at, what's the task being conducted, and so on. And also, they could also lead to miscalibrated trust in automation. And also, after being overly automated, there can be a degradation in understanding of how the automation is working, what's the rationale behind it. And this also could increase operational complexity, and it would also introduce new types of human automation failures. It could create bias, complacency, and increase cognitive demand and sudden workload transitions. Because the automation is working, hopefully correctly most of the time, and at times that it fails, and these are times that kind of be known as unanticipated events, the human operator is supposed to intervene and take over. And at that time, the operator, that's where we say that they are not in the loop anymore because they've been taken outside of that and automation has been taken over. So they can also be understimulated, and they can lose this vigilance that they have by just taking over this kind of a passive role that they have in operation in general. And also, of course, there's de-skilling. Things that operators used to know how to do is now being done by automation. And now the dynamics and the kind of skills that they require is very different. As it's similar to working with machine learning and artificial intelligence. Now they have replaced those kind of technologies, replaced a lot of tasks that are being done, but at the same time, that means that we need to learn new skills to work with them now. It doesn't mean that they have completely replaced humans overall, and we can, go on and be happy with life. We still have to do things. So one way to kind of mitigate these costs of over automation is with automation transparency. And that's really just the topic of my presentation today. And automation transparency in our kind of human factors and UX field is about facilitating human automation task interaction by disclosing automation's otherwise hidden complexity through a technology medium. And here, for instance, we are trying to see what's the automation doing and planning to do next in order to interact with it and accomplish a task. So what are the objectives of transparency? Oh, sorry. So some of the objectives of transparency is to support the understanding. So some of those, cost of over automation, and calibrate and resolve trust, improve human automation task performance, increase situation awareness. It all sounds so great. And we are like, okay, so we have found a solution to all these over automation and we can solve it. So if we make things transparent, we can work with overly complicated automation and hopefully we can, achieve these goals that we set to achieve. So we were interested in seeing how these hypotheses and theories that we all have and have been told by human factors, UX researchers and designers over time. And this topic of automation transparency is not new. It's been around for 40 years now that even Sheridan, Verplank, Schneiderman, all these kind of known, researchers have talked about feedback in a form of presenting information about automation to human operators. So we want to put it into a test to see how would it work out on actually decision-making performance of users. So we did an experiment, and I want to go a little bit into this experiment and what we did to evaluate the impact of automation transparency. The motivation behind this experiment and the application that we use in order to evaluate automation transparency is condition-based maintenance. I'll just in a high level describe what is condition-based maintenance. It's an application for artificial intelligence and machine learning for us, because it's one of the most prominent applications nowadays. And it, in a high level, it kind of consists of 3 steps. The first step would be the data acquisition step, where you have data from sensors on different equipments on a plant, or any kind of a situation where you have, collecting sensory data, or you would also have like event data that would come from maintainers who work on a piece of equipment or automation. So you have all these data, you put it into a machine learning model, it looks at all these patterns that emerge from these data, and it looks at, and then you have some, historical data that went some like certain sensors were at certain threshold, certain threshold that, for instance, the automation has failed. So you process that. That's kind of the black box here. And then you get a decision. You get, for instance, don't replace it, expect to replace this piece of equipment within this amount of time, replace it immediately. So now I had the sensors, I had this model that kind of did some processing and gave me a result. However, with the models and machine learning models getting more complex and complex over time, there isn't a direct link. Like I can't directly kind of say this is the input and that's the output, and that's exactly the equation that went on. Sometimes the models that we design, and like machine learning models, are kind of opaque and so complex that the developers themselves don't know why exactly it made such decisions. So the outputs can even be unknown to the developers. It's not just unknown to the users. So if the developer or our designers don't know the direct connection between the two, now we have to figure out different ways that we can understand how is this model making a decision in order to explain it to a person. So why do we need to explain this anyways? Like, why can we just keep it a black box? It's giving us output. It's great. Like, why do we need to understand it and unveil it? And one of the reasons for that, I think all of us are familiar with this, that humans need to check that the rationale aligns with the end user goal and metrics. And sometimes companies have their own kind of practices, and it's necessarily not always driven by sorry, there's some timing in this, not necessarily driven by these data. So they may have different practices that they want to incorporate into when you want to, schedule for maintenance. And also there needs to be, sometimes there's a need to verify that these validation and training data are representative of real world conditions. I can tell you an example in kind of plant processing. Sometimes you gather the data, and there's sensor data, you have the event data, and there might be some external conditions, like sometimes that can be like even, a certain lighting that's actually degrading the equipment's life health, but you don't have sensor data about that. You don't have that data. So the machine learning doesn't have that data. The operator that goes and does inspection regularly has that data and may understand the context around why is this equipment degrading and why does it so regularly need maintenance. But the human, the operator doesn't have that. The machine learning doesn't have that. So that's when we kind of might need to verify and get into the model. And also now, as we go into the next one, as it was really wanted to go to this slide, to like unveil this model and understand what's it doing. And now we want to incorporate these other contextual information that we have. Another reason that we may want to kind of motivated this experiment for us was that we were seeing, in theory, everyone was kind of saying transparency is really good, it's promising, it's giving you all these like task performance, trust calibration. It will solve our problems that we are getting with automation in general. But then in practice, what was happening in other experiments, for instance, was happening with other experiments was that there was a positive impact as there were some inconsistent and at times conflicting results of automation transparency. For instance, some experiments were seeing that there was a positive impact on human task performance and trust calibration. Some others were seeing negative impact, but also had reported better understanding. And the experiment was done actually in nuclear sector by my supervisor and his colleague in Halden Group. And they found out that the nuclear operators were performed worst when they were given more transparency, but the automation had become more complex, and but they trusted better with the information disclosure. So there was some, when they got more information, they had a better trust, but they performed worse. So these are inconsistent and conflicting results. So we wanted to see, let's add to it. Let's do another experiment to see what do we get from it. So my kind of like question that we were asking was, what are the effects of disclosing the rationale that led to a decision? by the machine learning on human performance. So some of those were like trust, reliance, task efficacy, and workload. So now we had to make kind of an apparatus, a platform first, in order to be able to run this experiment on it. 1 second, I think I'll see if I can, stop the kind of the timing that's running. Yeah, I think I think that's better. Okay. So first we needed to do this experiment, we needed to build the apparatus and an experimental platform that we can test out this kind of hypothesis that we have and these conflicting results that we are seeing. So we started, we developed in collaboration with a master's student, we developed a platform, experimental platform that's actually open source now as well. So it could be used by others who are interested in, testing out automation transparency in a context of condition-based maintenance, but you could change the way you visualize stuff. So that's a good thing that's also been used by other PhD students in our lab, and that's been helpful for them. So to give you a little bit of background, it works on open source hydraulic system data, and it has a machine learning model that predicts the condition of 4 hydraulic components. And these, like this process diagram here, don't want to bore you with this hydraulic system, but focusing more on the UX or HF side of it, this is, but just to give a context, this is like the components, and they were sensory data, and these sensory data were presented on the right side with the trends, and we presented the information about the machine learning that I'll go to with a bit more detail. So the machine learning itself, we had to configure it. As I said, when it becomes more complex, it becomes harder to kind of understand as a developer yourself, why is these decisions coming around, why the output it is what it is. So we had to kind of reduce the number of trees, the depths of the trees that these models were making, for instance, in this case, decision trees. And we also wanted to integrate some of the domain knowledge of hydraulic system to these sensor data, because they didn't want it to be solely just sensor data base. So after we kind of did our own, I guess in machine learning domains, they call like kind of feature engineering kind of way, and come up with a more optimal way or more simplistic model in this case, because it's our first experiment, to see, to lay out these rationale that led to the output of the model. So we did some of that work, and then we designed what we call transparency conditions that the participant would see and test for us what is the best way. So if you see like this dashed kind of box here shows the feature weights, and feature weights, it's for us is the relative importance of the sensors that went to that decision. Let's say, for instance, we were looking at a pump here, and there was some kind of a sensor that's very close to it, and those sensors would most likely be essential or influential in the decision making of whether this component's health is at a good rate or it's like degraded. And the other way that we showed that, again, very high level, we showed feature weight importance. We didn't get into like, taking out the equations and talking about every little bit of how the machine learning model works, but in a higher level, because again, we have to think about who's the end user. The end user is the operator that is knowledgeable in the operation side, but they're not necessarily knowledgeable in machine learning. They're not necessarily knowledgeable working with the algorithms and models and so on. So it has to be presented to them in a manner that they understand. And I think that's a very important thing when it comes to transparency, like understanding the end user and the audience. And that works very well with there is comparison in our field talking about automation and a kind of human being a team player. And I think you may have heard of this. And this is when we think back about humanities and what is being a team player, is that I may have certain knowledge in a certain context and domain, and I want to work with someone else in computer science, for instance, that has different domain knowledge, and we're working to solve a common solution. And we need to understand what my teammate knows. I need to understand, that person needs to understand what I know, and we need to communicate with each other in a way that, you know, it's not too overly complicated. It's not in a language that they don't understand. So this is very similar, like working with automation. It's very similar to that. You have to kind of think about all of these factors that it goes into effectively collaborating with someone. So the other condition that we showed people was the decision rules, which is kind of this green box here, which is very simplistic. And it says the estimation is based on the values of these sensors, for instance, pressure sensor 1, and it was the mean value of these sensors, and it gives you a threshold. For instance, it's saying if it was lower than this certain threshold, and because the pressure sensor was higher than certain threshold, that's the reason why I think that this valve is optimally switching and it's doing great. So it doesn't need maintenance at this stage. So this kind of the confidence probability was kind of giving our end users, you know, a cheat sheet, because our end user, I'll explain a bit about who it was. Actually, this experiment was planned before pandemic, and I was planning to get the Lambton College like maintenance trainees to participate in this, and you know, because we wanted to have end users that would be very realistic to in a real world situation. But unfortunately, pandemic happened when we couldn't get them. So we ended up using chemical engineering undergraduate and graduate students who had had at least taken a course in operations and processes systems. And we gave them this task to estimate the state of these components with from 3 different states. So for instance, let's say a pump, and they had to look at all these trends as like an operator would, and they would say if it's like optimally switching, or if it's like it's degrading in its performance, or it's about to fail, and that would determine what sort of maintenance action you would take. So this was a within subject design. It was randomized and counterbalanced, and that just means like the 24 chemical graduated students all saw different tasks. They were kind of given like games, like they had to like, you know, estimate the state of a hydraulic process, but they had all the information. It was all there, and the machine learning was giving its own opinion. So they had all this data to do it from scratch. They also had the machine learning opinion, and in some kind of scenarios, they had nothing about machine learning, like you know, background or rationale, or nothing, just that the machine learning had some opinion, and it was this. And then the other one was like local feature weights, and the third one was a decision rule, and the fourth one was a combination of both. So what we did, the outcome of this experiment was interesting. We didn't really find any evidence to corroborate that common belief that presenting the rationale actually positively impacted any of the dependent measures. We co-created this microboard that was used by other experiments, and ever since we have seen a better kind of, the other students have gotten results that are more conclusive about the impacts, and he's tried different ways of showing presentation. But this experiment itself didn't really show that much difference. When I spoke to the participant, not just relying on the statistical differences, there was a preference for feature weight importance, like seeing that bar graph was a preference for users. They wanted it. But a lot of time talking through the process, it seemed like even when the feature weight was present, because we had planted some scenarios where machine learning was actually making a mistake, and they had realized some of those, they had realized that every time they were given a new scenario, they would do this kind of this whole solving this scenario and case from scratch, from looking at the sensor data. There wasn't that much trust in what the machine learning was giving, because sometimes it would make mistakes, right? And we wanted to reflect the real world, because machine learning models could very well make mistakes, and that couldn't be 100%. And so that case, a lot of them were doing this from scratch. So as I said, this was the case where we could have provided the operators to come up with this whole kind of a status thing from scratch. But there may be some cases that there are a lot of data involved, and operators may not be able to, do this from scratch within an effective timing. So there should be ways where we could rely on kind of presenting the information or differently automating the task in order to get a better answer from, more effective decision-making processing. Anyway, so we did this experiment that was done. It wasn't very conclusive, not very significant data. And we were like, okay, let's add more to it. Like, we need more data, because a lot of time when you get inconclusive, non-significant data, it's because you didn't have that many participants. There's other reasons that can be involved. Like, so now we had 24 participants. So we looked at this method of, instead of doing another experiment of some other kind, we did a meta-analysis. I know it's not a very common technique. It's really common in in medical literature, because they look at all the other, kind of studies that have looked at an intervention and how did it impact patients, and they accumulate, gather all that data and see the impacts in a bigger kind of with a greater statistical power that could be offered by one study. So that's what we did. There've been a meta-analysis done in the human factors field, and we wanted to also try it for transparency, because we know other colleagues in our field have done very similar experiments to us, and they've looked at the impact of transparency. We are seeing conflicting results, but you can't rely on counting it by hand and saying, okay, this one is conflicting, this one, so we wanted to put it in some statistical model. So the objective was to estimate the observed effect of transparency manipulations and really test out, sometimes we're told transparency is a free lunch, and they really test out, is transparency really a free lunch? We get all the benefits, or was it just one study that we didn't really give us the best outcome? So just a little bit of a background about other people who have attempted to look at these transparency effects. There have been some kind of summative or narrative ways of looking at transparency effects. The summative claims are similar to how I described that you go to count if something is significant results in positive or negative way, and you basically count that as a positive and a negative. But however, there is a lot of flaws into kind of looking at those studies as individual, instead of looking at them in a statistical manner and looking at them in a model that you could take into impact, like account effect sizes and number of participants and everything, and not be so laser focused on just p-values. And I know people who are in the statistical fields know that the danger is of relying heavily on p-values, and if you get less than 0.05, it's great, and you can there's like a lot of emphasis on effect sizes in meta-analysis. And we were like, okay, so let's try this. Let's try effect sizes. First, we had to find all these experiments that I've done in the, our field. And I won't go through a lot of details. We just, set some eligibility criteria about what type of experiments, very similar to what I've done. Randomized controlled trials. They had to be in kind of vulnerable, uncertain situation. They had to describe transparency as a way of disclosing information, and they had to have comparison of some sort of transparency comparison. So I, for instance, compared feature weights with not disclosing anything with decision rules and then combination. So they had to have something like that, and they had to measure some human performance. Like trust can be done by questionnaires. Task performance it can be dependent on the task, its scenario. Situation awareness has its own questionnaires, and reliance as well can be based on the experiment task that you're doing. Workload as well has its own questionnaire, like NASA and other questionnaires. So after that, we kind of went through all these experiments. We looked at the other reference list and went through our eligibility criteria and find 46 experiments that had looked at the impact of transparency in some sort of automation. We weren't context specific because there aren't that many studies that you can say has been done in, like, for instance, let's say I did it in condition-based maintenance. Someone else may have done it in, automated vehicles. Someone else might have done it in like military context, nuclear, like all these type of contexts. They're all taken, like transparency is kind of, when I started it, was given to me as a free solution that, free lunch kind of, that it's showing everything, that's solving all the problems with all kind of types of automation. So it wasn't like it's a specific to a type. So we didn't, constrain ourselves to a specific type of context either. But what I found was that transparency is kind of a mess. Like that is like kind of expected, because there's different ways people show things. There are different ways, there are different tasks. And there is really, if it's a mess, I know that it's very context dependent, and that's in our field. But what makes things difficult is that you can't build on that knowledge, right? Because if my study is inconclusive, not significant, another one is similar, the other one is showing me different results, how do we use all of these to make the next step? Like, because I don't want to be the person that I'm just like laser focused on my study and I do the next thing in my study and this very specific thing, and it works in very specific ways. But if an industry partner wants to say, hey, should I be using transparency? I don't know. Like I know only in this very specific way that maybe, yes, it works fine. So that's not really helpful. So, and also when we wanted to compare things, we're asking ourselves a question: are we comparing bananas to apples? Like they're all saying that they're showing some sort of information and we want to compare them, but are they really that similar? So we wanted to first build a structure where we can find some kind of common ground that we can compare them from. So I kind of built a logic model, and these logic models to go kind of high level. Again, it's mainly done in like in medical sense, literature. So you have the proximal outcome of transparencies. So you have this improved task performance, no added workload, calibrated trust, increased perceived usability. And that's a very important difference between output of transparency and outcome of transparency. Because the output can be that I understand the automation, but this is the outcome that I'm looking for, is that I improve my task performance, my, decision-making performance. So we go back. So, and this is the, I'm coming from the back. So understanding, and how do we achieve all that understanding is the way we modify the information. So there are different ways of modification of information in this 46 experiment that I looked at, different types. People tried giving multiple different types. I talk about different ways. I give you information visually, textually, auditory. I also try to give you different information. I can talk about, predictions. I can talk about the current actions that the automation is doing. I can talk about uncertainty, historical data. There's so many different ways of talking about it. And then at last, we have the core element of the intervention, which is that disclosure of information in some format. And we have the intervention input, which are the information about automation. So now we kind of got a sense of, okay, if we group them in these ways, that different ways that they're looking at presenting information, maybe then we have a common ground. So we looked at kind of looking at assessing these transparency in a systematic way. So I talk a little bit about the active components of automation transparency, and I go to a bit of a detail here that it says, for instance, I disclose one type of information about automation, and then I don't disclose anything about it. This is one type of comparison. The comparison two is that I just increase this amount of information, right? So the comparison one is kind of like that. Imagine that one condition, and as I explained before, gives you information about automation status. Let's say it says, or it's uncertainty. Let's say that the machine learning decided that this kind of, system, or even like we can think about like, generalized application for even like making decision about giving a person a grant in the government, for instance, right? So it says, for instance, I made this decision because of X factor. And in the other condition, we have no more of that information is present. So you don't have that present, and you kind of build up on that condition. So this is the common ground that we are trying to compare all these studies from. And just to give you a little bit of, if you're not familiar with what is meta-analysis, just to say effect kind of size meta-analysis, in that you compute effect size, which an individual study would have, and the variance for each study based on the experimental design. Some of them are within, some of them between, and the sample sizes, how many participants, and some of the data that each researcher and designer provides. And then you compute a weighted mean of these effect sizes, and we use a random model effect model, which means that the true effect sizes really does vary between one study and another. Not all these studies are identical. Yes, we did try to find a common ground, but they're still not identical. And then we compute a distribution of true effect, which I'll tell you why that's useful, and confidence interval. So now we have all these other studies that we put together, and we want to look at what's the effect of that. So I want you to look at on the right side where you have all these kind of, lines here, and these are showing an individual study. So anything that you see after 0 shows the effect size showed positive impact about transparency impact. And that's when you showed one type of information versus not showing anything, right? And anything you see before it showed that it favors actually not showing any information. So you see that it is, again, conflicting. Like we have all these the studies here, but the overall kind of effect size is not even considered small. It's 0.112, and the confidence interval tells us how precisely we have estimated the mean effect size. And then we have the lower limits. You see it also crosses 0. So the lower limits is negative, and we have the positive, which means that the mean effect size is somewhere here in the universe of comparable population. So that means that the effect size of transparency can be 0. And we cannot conclude that on average of all these experiments that other colleagues have done, that transparency actually improves task performance. So and also another concern is that if the effect sizes vary so much from one study to another, which is the case here, we kind of should focus on the dispersion of the effect, range across which, that is the range across which the effect size varies. And I can talk a little bit about that. The question is that we're asking next is that when is the transparency beneficial? When is it harmful? Right? So that's what I want to know now, because I know that I can't say for sure transparency is always a thumbs up, right? So I want to understand when is it and shouldn't use it, when is it good to use it, right? So we have this kind of assessment, right? We use the first one for the comparison, and now we're doing kind of subgroup analysis. So now we are looking at if the task that the participant were given were identifiable in terms of why transparency was beneficial or not, and the participant skills. All of these can have an impact, right? Because a participant who is more knowledgeable may perceive the information very differently than a participant who doesn't have any knowledge in the domain that they're being asked. So we group them, we group all these studies. We didn't have that many, studies in each of these groups. So these studies are grouped by the type of a task. That also didn't tell us why these transparency studies are so different. So that wasn't very helpful. And then we also did the kind of task, the skills of the participants. So one of these studies, for instance, the participant had very basic skills. One of them have very high skills. And these ones are kind of intermediate, but that also didn't tell us why transparency was so different. You can think of so many different ways. I'm sure everyone can think of so many different reasons why transparency sometimes is harmful and sometimes beneficial. But the systematic ones that we can put into a model to look at were these ones, right? Because sometimes there are speculations in the literature saying that if automation is very complex, then transparency is not useful, right? Because no matter how much you show the information, it becomes very hard for the person to, understand it, consume, process it, and perform in a certain way. So, but that's a speculation. That's a hypothesis that has to be, tested more and more and more. But systematically, we don't have an answer for this question. So if a industry person or partner asks me, if I implement automation transparency in a new system that I'm building, what should I expect the impact of this transparency to be? So the answer to that is somewhere from negative 0.25 all the way to positive 0.3. So it's like this says that we can't rule that transparency can have positive impact. You see, it does have impact, but the very likely that you get no appreciable and a slight chance that you get a very small and moderate impact by building transparency into your new system based on the data that we have available in the human factors literature right now. So that's what I think kind of maybe not so satisfying answer, but maybe the most accurate answer that we can give at the time. And this bell curve, it kind of gives you the idea that the effect size are expected to be normally distributed between this range. And the wider the kind of the curve reflects the uncertainty in this estimate. And you see that's quite wide. So there is a very uncertainty about the impact of transparency. There's, of course, limitations to this study. They are incomplete reporting in the literature of, or selective reporting of data. And that's why we would always benefit from open source data, open data from the experiment that we could use to build, open those knowledge that is being created. There's always a risk of publication bias. The studies that are non-significant, inconclusive results are not very favorable, unfortunately, in the world and are not very published. So there can be some other, PhD student somewhere in the world doing similar thing as me and not getting their papers published and it's not being used. So that's unfortunate because those could be very useful. And as you saw, the struggle, the studies are not comparable. We make our own platforms, and some other researcher makes some other platform, and now we have very differences of how it is, and that we want to compare them. And then also, I just looked at task performance, which can the accuracy of your just replying to a task, but it can be meta-analysis can be done on trust, workload, and situation awareness. And that's something for the next person to do, but it would be very interesting to see how is the accumulative kind of impact on these other measures than task performance. I'm kind of coming to the end. I don't want to bore you too much. So should automation be transparent? Transparency is being presented in the literature as a means to improve human performance, but we saw very little evidence through this statistical examination and the empirical examination that is in fact a generalizable principle. And I like this kind of rolling a ball, maybe ask again later. So we need better analysis of the existing evidence. We need to fill in the missing data that we have in the literature. We need to assess study quality, the risk of publication bias, and apply more standards in the way that we report data, and also apply more standards in the way that we, build on each other's kind of results from one study to another. So that way we can build on and maybe come up with a more definitive impact on automation transparency. And and this wouldn't be possible without the help of my mentors from University of Toronto. Of course, Professor Greg Jameson was my supervisor, and he's helped me enormously throughout this whole 6 years. And Chris Beck and Olivia were my committee members, and there were other people that have helped me throughout this process that I like to acknowledge here. And I hope you found this interesting and useful, and I'll be happy to answer any questions that you have. Thank you so much.